These are notes 15, the first notes for this week. Make sure you set up your paper just like mine. You should already have this done from the beginning of class. So we should have a nice little diagram of what a parallelogram looks like. So we're going to get started with some theorems about parallelograms. So what I did is I made 3 columns there's going to be several theorems. So I made 3 columns so that this can be organized in a way that makes sense. So pause if you need to. I'm just going to show that much for right now. And I'm going to highlight just to kind of show you guys what this is. So here are several theorems about parallelograms. We have our if, then, and then a pick to describe it. And then I've got theorem 40. And then you can see there's going to be another theorem after that, and then another theorem after that. But they all go along with this same if statement. So I'm going to emphasize that as we go, that it's always the same if. Okay, so I'm going to go ahead and get started explaining this, but you guys pause it as you need to. So it says, if a quadrilateral is a parallelogram. So by definition, the parallelogram is a quadrilateral with both pairs of opposite sides parallel. So you've got parallel sides here and here, and then parallel sides here and here. Okay, so it's going to be the same if for each theorem. So you're going to read this and then go across, and then this and then go down, and then this and go down again. So if a quadrilateral is a parallelogram, then opposite sides are congruent. So for the first one, I'm going to just separate this with yellow. And again, we've got our 3 columns like that. So this whole top part is theorem 40. So if a quadrilateral is a parallelogram, then opposite sides are congruent. And so here is a diagram showing that. So opposite sides are congruent would mean this side AB is congruent to that side CD. So they have the same measure. Congruent sides have the same measure. And then these sides, top and bottom, have the same measure as well. They're also congruent. So you can tell by the markings if they're congruent with each other. And again, pause as needed. So there's going to be several theorems, and we'll sum it up again near the end. So here's another theorem. I'm going to slide that up a bit. Theorem 41 says that consecutive angles are supplementary. So I didn't draw another parallelogram just because it takes up kind of a lot of room. So you could look at the picture of the parallelogram over here. So it says consecutive angles. Those are angles that are like right next to each other in order. So the measure of angle A plus the measure of angle B is 180. So look at where A and B are. So it's like any of the 2 angles that share one side. A plus B equals 180, and then measure of angle B plus measure of angle C equals 180. So see how those share a side. And then measure of angle C plus measure of angle D, they add up to 180, C and D right there on that side. And then measure of angle D and measure of angle A, they add up to 180. So any 2 angles that are consecutive, they add up to 180 degrees. They are supplementary. Consecutive angles are supplementary. And then theorem 40 up above was saying opposite sides are congruent. So they have the same measure. Okay, here's another theorem. Again, pause as needed. If you need to continue on to another page, you can, but hopefully you can fit it like how I did. So this one is theorem 42. And just remember, we are reading the same if statement. So if a quadrilateral is a parallelogram, if it's like this, parallelogram, opposite sides are parallel, then opposite angles are congruent. So up here we had opposite sides are congruent, now we have opposite angles are congruent. Opposite are the ones across from each other. So angle A is congruent to angle C, and angle B is congruent to angle D, with 2 arcs for that one. Okay, so let's just say, for example, maybe measure of angle A is 80. Well, then C is also 80 because they're opposite. And then A and B are supplementary, and so are A and D. They're sup. So if A is 80, B has to be 100 because 180 minus 80 equals 100. So A, and just for that example, A and C would both be 80, B and D would both be 100. And then the consecutive angles are supplementary and they would all add up to 180, but opposite angles would be congruent. All right, and one more theorem. Let's see. I have one other color to highlight, so I'll use this color. Theorem 43. We're still using that same if statement. So I'll go and read that. It says, if a quadrilateral is a parallelogram, then diagonals bisect each other. The diagonals are the lines that go diagonally across. Bisect means they cut them in half. They make two equal parts or two congruent parts. So diagonals bisect each other. So that means each diagonal gets cut in half. So we have AE is congruent to CE. So that's this part in the middle. AE is congruent to CE right there. Those would equal the same. So maybe the whole diagonal was 20, and then at E it cuts it in half, so it's 10 and 10. And then BE is congruent to DE. So maybe BD, the whole length, maybe that is 30, and then it gets cut in half. So that would make 15 on that side and then 15 for DE. Okay, so that's diagonals bisect each other. And basically just draw the parallelogram and then make a straight line from one angle to the opposite angle, and then another straight line from one angle to the opposite angle. The point where they meet is E. For this one, it's called E, and it's the midpoint of each diagonal. Okay, so what we'll do next is we'll do some examples in the book. So I'll slide it up so you can see. Bookwork is page 272 to 273, also page 276. So just to review the theorems that we went over right now, it's all saying the same if statement. If a quadrilateral is a parallelogram, if opposite sides are parallel, then all of these are true. So opposite sides are congruent. Opposite sides are equal. Consecutive angles are supplementary. Any two angles in a row add up to 180. So if you know one of them, you can find the other. Opposite angles are congruent, so the ones that are opposite each other, like B and D or A and C, they're congruent. And then diagonals bisect each other. So if you draw the two diagonals, they cut each other in half. So they split each other in half. Along the whole diagonal, it's cut in half. All right, so we'll do some practice in the book, starting with page 272. All right, so here we are on page 272 in the book. It's 272. It says, find the value of x in each parallelogram. So it is a parallelogram. On number 1, we're looking at angles and 2. So you need to remember consecutive angles are supplementary. They add to 180. But opposite angles are congruent. So just to show you, 53 would also be right here. Opposite angles are congruent. And then x is also over there. But for those two, any two in a row, any two consecutive, they add to 180. So the way I would solve to find x is I would do 180 minus 53 and subtract that, and it would be 127. So I just have to write x equals 127 degrees. Okay, but I could find all four angles given only one angle if I know it's a parallelogram. So I'll do something similar in number 2. I have to find x. So just looking right here, I see, oh, they're consecutive angles. So I just have to do 180 minus 113, and that gives me x. So I just have to subtract, and I get, 67. So x equals 67 degrees. But just to show you all the angles, if x is 67, then it's 67 also there. And 113 go across, 113 is also there. And x is 67. Okay. And then just to show you guys, in the book, it does have those theorems that I just went over. So feel free to look at these diagrams. They draw them nicer than I do, so it's always good to see that. So that's page 272. And then let's go ahead and look at the next page over, 273. I'm going to skip this proof for now at least. I don't know, we might come back and do it, but I wanted to do this one with you. There's going to be one similar to this in the homework assignment. So let's go ahead and do this one. So I am given this symbol right here. That means parallelogram. Just like how the triangle means triangle, this symbol means parallelogram ABCD. So we're given that this is a parallelogram. If you want, you could mark. That would mean that this side AB is parallel to that side CD, and that the top and bottom sides are also parallel. Given that it's a parallelogram, that's really all that I can mark because that's the definition of a parallelogram. What we need to prove is that segment AC and segment BD bisect each other at E. And so that's that last theorem that we went over, theorem 43. So we are actually going to go through and prove that the theorem is true. So we'll just go through and go step by step. So the first statement is our given, and they even put given. ABCD is a parallelogram. Now we have AB is parallel to DC. So I see AB is parallel to DC. That's by definition of parallelogram. That's the only thing that's by definition of parallelogram, that the two opposite sides are parallel. Anything else is a theorem. All right, and then what it has is angles that are congruent. Angle 1 and 4, so 1 is here and 4 is here. And then 2 and 3. I'll do 2 marks for 2, 2 marks for 3. It's a little bit hard to see, but try to carefully do that. And I want you guys to think, how can we know angles are congruent given parallel lines? See how it goes from parallelogram to get parallel lines. Now we have congruent angles. So if we extend those parallel lines, and then if you look cut by transversals, I'm noticing we do have alt interior angles along that transversal. And then if we look along this transversal, we have alt interior angles. So it's if two parallel lines are cut by transversal, they're both alt interior. There's two pairs of alt interior angles are congruent. So try to fit that in there. If two parallel lines are cut by transversal, then alt interior angles are congruent. All right, and then the next part is that segment AB is congruent to segment DC. So I'm going to grab a different color and mark that. So AB is right here. So now it's saying that those two sides are congruent. And so the reason for those two sides being congruent is if we look back at the notes, it would be theorem 40. So we can use theorem 40 as a reason. It's if a quadrilateral is a parallelogram, then opposite sides are congruent. So you can see that side AB and DC are opposite sides. That's just a lot to write right there. So I'm going to try to write it real short. If I'm going to use the symbol for parallelogram, ABCD. So that means if we have parallelogram ABCD, then opposite sides are congruent. Okay, so if parallelogram ABCD, then we know based on the theorem, theorem 40, opposite sides are congruent. Okay, so going forward to number 5, I have to fill in here, and I know it's ASA. So if it's ASA, I know it has to be two triangles that are congruent by angle, side, angle. So looking up at this parallelogram, I see 4 small triangles, and even like if you cut it across the diagonal, you could see 2 larger triangles, or the other way, 2 large triangles. So it is a little confusing to see what are the 2 triangles, but focus on the ASA. So I have angle 1, then that side, and then angle 2. So I'm going to just trace it kind of darker in my pen to let you guys see. It's basically like a bow tie, kind of like that. 2 of the smaller triangles, but right there and there. So I just have to name them. So I can name it ABE. And then the one that corresponds with A is, it was angle 1 and 4, so 1 and 4. So it would be C. CDE. CDE. So triangle ABE is congruent to triangle CDE by angle side angle. And then it's got segment AE is congruent to segment CE. So AE is right here and CE is right here. So that's across the diagonal. And then BE and DE right there and right there. So what I'm noticing is those are actually all parts, like those are sides of the triangle. So I'm going to write a little note there. These are sides of the congruent triangles from number 5. So all of these sides that are congruent, they're the other sides of the little triangles that we said are congruent in step 5. So this is actually CPCTC. Corresponding parts of congruent triangles are congruent, and the parts are 2 of the sides. Okay, and that leaves us with the last statement. The last statement is always what we're trying to prove. So AC and BD bisect each other at E. And that's by the definition of a bisector. So if you look at the way these are marked, AE and then CE, it's along the bisect or the diagonal. And if they are both congruent, then it's bisected. Same thing for the BEDE. From BE and DE, it's along the same diagonal. And if those are congruent, then that segment is bisected. So that's definition of a bisector. All right, and then we are going to practice just a little bit more. So pause if you need to write that. We are going to do page 276. Just a little bit more to practice before we get to the other assignment. So for exercises 8 through 11, use the diagram of parallelogram ABCD to find each value. So we will be using all of the theorems. So look back at your notes. Opposite sides are congruent, consecutive angles are supplementary, opposite angles are congruent, and diagonals bisect each other. Actually, we're not doing the diagonals. We're just doing the first 3. So the first thing is find measure of angle A. So here's A. I know that opposite angles are congruent, so I might look and see if C is given, but it's not. A and C would be congruent, and B and D are congruent, but all I'm given is angle B. So since I know that consecutive angles are supplementary, I can do 180 minus 127. So if they're angles right next to each other, they add up to 180. If they're angles across from each other, they're the same. Okay, so I just have to borrow and finish solving, and I get 53. Measure of angle A is 53. So A is 53. I'm going to fill it in just so you guys can really see how this works. And C is also 53. Notice that angle B and angle C would add up to 180 as well. And then I know B and D are congruent, so I can write 127 down there for D. So I'm just showing you extra information so you can see how those theorems work. Consecutive angles, any 2 in a row, add up to 180, so you can check that. That works out. But opposite angles are congruent. Oh, and so I already found for number 9. Number 9 is measure of angle D, but it's the same as measure of angle B since they're opposites. So 127. And then number 10, I have to find X. So X is part of an expression for the side length of BA and DC. So I know that opposite sides are congruent. Opposite sides are congruent, so I can set them equal to each other. Opposite sides are congruent, so I can set them equal. X plus 2 equals 2x minus 3. And then I just have to solve for x. So I like to keep my x's positive, so I'm going to subtract x to this side. And then make sure you know where the middle is for the equal sign. So 2 equals x minus 3, and then I just have to add 3 to the other side. So 5 equals x equals 5. You can check by substituting that in if the sides are actually equal. So 5 plus 2 is 7, and then 5 times 2 is 10. 10 minus 3 is 7. So I just kind of checked it. I didn't write it out because those are easy. I just did it in my head. So if you substitute in the 5 for x, work it out, each side does equal 7. Okay? And then, okay, well, I kind of went ahead. Number 11 is asking for AB. That's the side length for AB, the measure of AB. I just found that out. It would have been x plus 2, and then you substitute 5 for x. 5 plus 2 equals 7. So AB equals 7. Okay, and that's it. We're not going to do number 12 or any of the other problems. So this is it for the notes, and then you just have to do the assignment that goes along with the notes. Make sure you do a summary and 3 questions on the left on your notes. Always do that.